So we've gone through the design, and we teach you relational data modeling, and now we're stepping back and going into more detail, in more theoretical details and the principles that you learned, and now we reinforce those principles. So basically, when you design a database, you use a methodology. In your what you've learned in the last few weeks, the data-based design methodology was relational databases, ER diagrams, entity relationship modeling. So there was a tool with certain notation, entities, relationships, multiplicities, and all this information that goes on the ER. So we basically use methodologies in our design, be it a database, be it normal programming that you learn. And these methodologies basically have got their tools that provide you with certain notation, certain facilities to express your understanding of, for example, a given problem in this case. So what we can say about a methodology, it's an approach that basically provides you with certain techniques, certain tools for representation, for documentation, in this case, of a design of a database. So what you learned was entity relationship modeling, and we went straight away into this methodology and to talk about data models and tell you what to do, and show you the notation. What I want to do today is I want you to relax, sit back, and I purposely actually cover this chapter, because you read it, and most of you come back to me and say, this is really very long chapter, it's very repetitive, and I really don't know really where to stand among the whole thing in this subject. And what I want you to do is spend 5-10 minutes, pay attention to what I am saying, and you save yourself hours of reading of this textbook and in this chapter. So of course you will be reading the chapter, it will take you a couple of hours, but now when you read the chapter you understand what it is about. So what I said to you is we use methodologies, which are techniques, procedures, activities, notation, that gives us a tool for basically performing certain activity, in this case designing a database. So these methodologies can be used for different activities. So in this case we're talking about building a database. We'll start designing a database. So to do that, in computer science we use this database design methodology, and the database design methodology tries to break the design into parts and provides you with different tools to solve each part, and then combine all these parts together, and then you have got the complete design. So in the database design methodology we talk about three phases: the conceptual, logical, and physical. In a sense, you have done the conceptual and logical database design in your assignment 1. Because what is conceptual database design? So what we want to do is, when we look at a problem given to us, a scenario, read the assignment 1, assignment 2 be one of the questions in the tutorial or in the exam, you have to use this methodology if you want to be coming up with a good design, and with not lots of pain. So painless solution is a very good thing, and with less headache. So what we are saying is, given the problem specification, you read the problem specification, and in the first reading you try to basically find out what is required to be done. What is this problem? In this case, for example, in assignment 2, this is bank, I've got customers, accounts, I've got insurance, also provide insurance policies. So this is the first read of the specification, figure out what it is required. At this point, if you start thinking of the database itself that will be built, if you start thinking about Microsoft Access, the queries that needs to be written, okay, the user interfaces that needs to be built, the reports that needs to be built within that database, the data dictionary, and ER diagram, all at the same time, you'll be very overwhelmed and you become very tired. And your mind is all over looking for solutions for every bit and piece. So the whole idea of this database design methodology is like you concentrate on certain tasks and you build upon each task. The first task, read the scenario and understand what's required for the problem given. And then, from that, once you understand what the problem is, try to identify the entities and attributes of each entity. So this is basically the first stage of the database design. Reading the problem, understanding what's required, the general overview, and then finding just the entities and attributes of each entity. Not even thinking of the primary keys at this point. Alright? So we break the design into three parts. One is first, what the problem is, find the entities, find the attributes. Right? Don't think of, am I going to build a relational database or object-oriented database or what kind of database? Just figure out what's required, the data. The next is finding the relationships among entities, thinking of a kind of data model that you want to build. In a sense, in what you know is relational data models. So you think of relational data models, and now you look at your conceptual model that consists of all the entities and attributes, and now you're figuring out what are the relationships between these entities, then normalization. Okay, once you've done that, and created your data dictionary that we'll talk about, the next step is to go and start thinking of building the database. Right, because the design is in front of you, you know all the entities, you know all the attributes, you know all the primary keys, you know all the foreign keys. It's all normalized, so there's no thinking of design anymore. We just concentrate on implementation. So we just read the document that's given to us and we implement the database. So that's why we use this three-phase database design methodology. The first stage is to figure out what data requirements of this organization is based on the specification, finding the entities and attributes. The next stage is figuring out what kind of data model I'm going to use. For example, all you know is relational models, so then finding all the relationships by reading the scenario again, finding all the relationships, setting all the foreign keys, doing normalization. Once that's done, creating your data dictionary, you'll learn about it today. And then, once this document is there, you start clicking and opening your Microsoft Access or SQL server and start building your database. You don't start building the database when the design still is not finished. So you don't build as you design. You design, right? You understand the problem, then design the model, then you build. And this is the whole idea. Once you design you are finished with your design, you can now start thinking of basically which database management systems you will be using, Microsoft Access or SQL, Microsoft SQL or Oracle or any other database management system. And then you think of how much storage you need, what kind of other tools you need, when I talk about tools here, how much storage you need, what sort of hardware you need, what's the demand on your database, and then you start building the database. So you think of the demand, storage, facilities, and build when the design is finished. So we have got three phases: conceptual, logical, and the physical database. So let's talk about conceptual today. Only you all know what it is. I will go through the steps. There's lots of steps here, but you know it all. You should not be getting confused. And we're not going to ask you, tell us what's the first step, tell us what's the second step, what's the third step. So say conceptual database design, you ask you maybe what's a conceptual database design? You know, and then, you know, what's involved in the conceptual database design? And you should be able to answer us, not based on the book that you just read, the lecture notes, but also on your experience, because you've done two big assignments, couple of scenarios in the tutorials. You should be able to just say, okay, given a problem, what did I do in the first phase? And here it is. What you did was, you started with the conceptual level unconsciously. You did that, and that's what we did teach you. Basically, without telling you what a conceptual level is, we did teach you, and now we tell you conceptual level is when you get a problem specification, read it, and what do you do when you read the problem specification? What's the first thing you find out? Entities, attributes, the domain of attributes, the type of values that attributes will have. Okay? So basically, after you read the scenario, you find the entities, attributes, you think about possible primary keys, or the candidate keys, or the attributes in your entities that could become a primary key. Right? That's what you do in the first stage. And that's what is called the conceptual database design. So you don't need to memorize. You have to think. If you think of the database implementation, design and implementation into three phases: conceptual, logical, and physical, and the conceptual is the first stage. Then you get a problem specification. What do? You read the specification, you identify the data, and basically sort them out into entities and attributes. For each attribute, you think what kind of data type it would be. It is a number, a text, a date, currency, whatever it is. That's what you do. Right? So nothing difficult. Once you find all the entities, or once you identify the entities and the attributes in that stage, then you think of primary keys, because you work in the relational data model. You think of primary keys, but you may not still be sure what should be the primary key. Right? So, and the next thing is, you check, you read the scenario again. Have I missed any entity? Have I missed any attributes? That's what you do. Check for redundancies. Check your entities and attributes again. And you basically at the end of your conceptual database design. So none of you really requires to read all the chapter again or all the lecture notes. If you go back and look at how you design your database, and hopefully you followed all these steps. Because given a problem, a specification, what did you do? Read it, find the entities, find the attributes, right? And think of any attribute, the type of values for each attribute, the domain of values for each attribute. Then you read the problem again, you look at your first design or first solution and see if there is any entity I missed, any attributes that I missed. Maybe I put the attributes in the wrong place with the wrong entities. Is there any redundancy? So, and that was it. That's a conceptual database design. So it consists of many steps, but that's it. But the next step, what you did was, then you went and set the primary keys, set the foreign keys, find the relationships, and basically use the relational data model. And then the next step, creating the database, which is in the physical part of the, and think of this data, the storage needs, database management system that you're going to use, etc. So let's go back again, and I'm going back again to your textbook, because many of you read this chapter and get very overwhelmed and confused sometimes for no reason. And then you come and see me, and when I tell you, you're already doing this, there's nothing about it. So you just have to explain it, right? What it is. So basically, to build a conceptual database designing a database in the conceptual level, basically you find all the entities, attributes, right? The type of values that can be stored in each attribute, and then review, get rid of any redundant attribute that you have got in several entities that's not necessary to have it, for example, any entity that you missed. Look at possible primary key and foreign keys. You don't set it at this point. You don't set the primary keys. You consider what could be the primary key, okay, and then review. That's what's conceptual data model. Hopefully that's enough for you, because if you look at each step that I show you here, consists of several steps, but you all know it. So we're not going to ask you, tell us what's a step 7 or a step 3 or a step 4, but we may ask you in the exam, what's a conceptual database design? Why you go through these 3 phases? And of course the answer is this: you go through these phases because you try to break the problem into simpler problems, and that's what computer science is about, and solve every simpler problem and then move on. In this case, you look at the whole problem at once, but first you look at finding all the data needs of the organization based on the scenario, without thinking of what kind of database management system I'm going to use. Is it Access? Is it Microsoft SQL? Is it Oracle? What sort of data model I'm going to use? Is it going to be a relational model or any other? So you just concentrate on finding the data item that the organization needs. In the conceptual level, finding the entities, attributes, and reviewing, getting rid of redundancies, not normalizing, no normalization at this point, right? And that's all it is about. So maybe this lecture is going to be short. What I want to talk about, I want to show you a few bits and pieces from your textbook, and then there will be basically full on lecture on data dictionary. So I just want to show you a few bits and pieces, and then probably next week go through full details of data dictionaries. What you need really is this, and we're in the conceptual level anyhow. After you've done the conceptual level, you do the logical database design, which we'll talk about in details next week, which is basically setting the primary key, finding the foreign keys, and applying normalization, and finishing the design. When you finish the design at this stage, because in the conceptual level you have thought about what kind of data types each attribute should have, each attribute of each entity. And you need to write it down, because when you start building the database, when you start using Microsoft Access, for example, in your assignment 2, you should not think of design. You should just think of building this application, and the design is ready. Right? So, and when the design is ready, it shows you all the entities, attributes, primary keys, foreign keys, and also for each attribute, it will show you, you will have a document that's called the data dictionary, which is the definition and explanations of each of attributes and entities of your design. So what we're saying here is, you need that, because when you start designing, you need to know the name of the table, so you find it from the entity. Translate each entity into a table. The primary key of each entity, you have already got it in your design. It's underlined. You set it up, right? But for each attribute, you need to know what type of data this attribute that you have. Is it a number? Is it a set of letters? A text? A date? Is it a currency? Is it a number with a decimal point? What it is. You should not think about it at that time. It's done in your design, as part of your design, and that's what's called a data dictionary. So for each entity, you say what that entity is, the entity name. You will have a document, you can open a Word document with a couple of columns. Entity name, the description. For example, in this case, the staff is the general term describing a staff or employees of this company. For example, this for Dream Home database. So, any aliases? So, are staff known as something else in this company? Yes, they may be known. In this case, employees and the staff are the same thing. But what's your entity is the staff. What's the table relating to that is the staff. So, so for each entity, you will have a description. You know all the aliases. Fairly easy. Okay. And then you do, of course, your ER diagram, which you've done it. Then the multiplicity, that means they relate between two entities or two or several entities, their relationships. What kind of relationship is that? You have to say that multiplicity. The multiplicity, you can work it out from your ER diagram. So the data dictionary is done after your entities, attributes, primary key, foreign keys are set. Your ER diagram is drawn, and then you basically write definitions of every entity, and then the relationship that exists between each entity. For example, a staff has got a 1 to 100 relationship to property for rent, and 1 to 10 to a staff. So basically what we're saying is, if you look at this, each staff manages 100 properties, you see? One staff, 0 more staff, manage 0 to 100 properties. And then one staff supervises another 10 staff. So that's what comes from your ER diagram. So if you go through this methodology step by step, it's all built up on each other. So now you have got this information. Right? So for example, property for rent has got a one-to-many relationship with the lease. So we can work out property for rent has got one-to-many relationship to the lease. So this is the document that comes as part of your data dictionary. The next thing to do is, for each entity now that we have identified, or basically described, and the multiplicities of all the entities identified, the next thing to do is to go through and write a description of every attribute of every entity. So for example, table of staff, what are the entity of staff, what are the attributes, the staff number, first name, last name, position, sex, date of birth. What it is, the staff number is a unique number, identify a member of the staff, it's a primary key, you can say here. F name is the first name, L name is the last name, position is job title of each member of the staff, sex is gender of the member of the staff, date of birth is DOB. And here you say the type of the values. The type of values that this attribute can have. In this case, 5 characters or 5 letters and numbers, 5 characters for the staff number, first name 15 characters, last name 15, position 10, sex 1 character, male or female in the sense M or F, and date of birth is of type date. Can they be null? The first one cannot be null, for example the staff number, and then name has to be there, position has to be there, name has to be there, position can be null, and date of birth can be null. So that's what the company wants. None of them are multi-valued because we don't, we have got a normalized database, so we don't store any multi-values there. So here, and you continue with the rest of the entities, property for rent, and then all their attributes, etc. So imagine having this. So you have got this data dictionary, you can put in front of you to start building your database. The name of the table from the entities, the name of the attributes is described here, the type of values for each attribute is there. Is it text, is it number, is it date, it's currency, whatever. So you don't have to think now back to design. It's all there. That's why we do it.